Okay, guys, so we are going to write the equations when given the piecewise function graph. So looking at example number 1, these are solid circles, which are going to matter when we set up our domain. So first and foremost, what I would do is just take it step by step, so don't get overwhelmed. These are horizontal lines, so that means we know that they are going to be y equals equations. So if I work on the first one, closest to the x-axis, so this guy, it crosses the y-axis at 1. So we know that this is going to be y equals 1. And then if we check out our second one, again, it is still a horizontal line. So that is going to be y equals 3. Because if we extended it all the way through, that would be at the 3. 1, 2, 3. And then up at the top, our last one, it's going to also still be a horizontal line. So we just got to figure out where would its intercept on the y-axis be. So 1, 2, 3, 4, 5. So y equals 5. But the part you have to pay attention to is your domains, because these aren't extended lines with arrows. They actually have the finite dots and then open circles as well. So we can write f of x, and we have one function, so y is going to equal 5, y is going to equal 3, and y is going to equal 1, no matter what. And you could also have seen that written just if f of x is 5, so the y's could actually go away. So probably on most programs, you're going to see 5, 3, 1. Because remember, f of x is y. Now we have to set up our domains. So this is going to be x domains. So that means you're only using x values, right? So we can go ahead and put an x, and an x. So it is going to be 5 only from 1, 2, 3, 4, from 4, because that's a solid circle. So 4, and then to the right. So when x is greater and equal to, because that's a solid circle, until it hits 5, 6, until it hits 6. But it's not equal to because it's an open circle, so it's less than. So that's setting it up from 4 with a solid circle all the way to the right to 6 with an open circle because there's not an equal to. So now looking at 3, so our green one, it's at 2 is where it starts. And it's going to the right, so that's when x is greater than. It's equal to because it's a solid circle. And then 2 over, so that's going to be all the way over to 4. Again, that's an open circle, and where it left off here, so it's less than, because from 4 it's going to the left. So for the last one at the bottom, it's going to be from 0, because that's where it starts. Then it goes to the right, and that is a solid circle, so you get that equal to. And then it goes to 1, 2. But again, it's an open circle, so no equal to. And it's to the left of that open circle. All right, so that's our first one. And those are 3 horizontal lines, right? Okay, so example number 2, we still have another just straight line and another straight line. This is a horizontal line again, and it is passing through y equals -2. So y equals -2. Looking at our diagonal line, things you want to discuss with yourself, you're going to need slope, y-intercept. Is it positive or is it negative? So if you're thinking y equals mx plus b, remember m is our slope and b is our y-intercept, just as a reminder. And that's the form that's going to be the most easy to write these in. So if I look at this guy, it has a slope of up 1 over 1, up 1 over 1, up 1 over 1. It is increasing left to right, so it is going up, which means that is a positive slope. So I know it's going to be y equals something x and then something. So since it's a 1-to-1 positive slope, we can put a 1, or when we write it in a minute, we'll probably leave the 1 off because that's usually the way it notates. You want to extend it through and see that it's going to touch your x-axis at 1, 2, 3, 4, 5. So that's going to be plus 5. So we have f of x, or you could write g of x, or your initial of x. So I could write s of x or j of x. So it's y equals x plus 5, and then y equals -2. Horizontal line. Now we have to just set up the domains again. So the domain, remember, again, you're just focusing on your x-axis. So we're only looking at these numbers for our domains. And where we extended doesn't count. We're going with what they had on the graph. So we know that from negative infinity, so this way is this line because there's an arrow here. But it comes over only at -2. It starts at -2 and then it goes to left forever. So we know we're doing x values. And this way is less than. So this is negative infinity, which is going to be less than x. And then if you go to the right, it's positive infinity. And that's greater than whatever that number is, if it's going from that number to the right. So we have an open, which means we know we're not going to have an equal to. So it's going to be x is less than -2. Because when x is -3, it's going this direction. When it goes to -4, it's going this direction. But as graphed, when I went to -1, it's not there. When I went to 0, it's not there. And so the functions flip. So here at -2, it starts at -2, and then it goes to the right. So that means when all numbers are greater than, when x is greater than -2. And that is a solid circle, so we're going to put an equal to. All right, that's your first two examples, guys.